Hi, this is Zhao Fan. My project topic is image transformation based on turbo code. Since the 21st century, there has been a growing demand for efficient and reliable digital information transformation and storage systems, and the application of error control coding has become an integral part of design of modern communication systems. And, and the transmission and storage process of digital information have many similarities in that both require transmission from a source to a host. This is a block diagram of a typical data transmission. My project is mainly to analyze these things through experiments. The first is to analyze the effect of noise in data transformation. The second is to analyze the transformation performance of convolutional code and turbo code. The third is to analyze the effect of interleaver of two turbo code on image transformation. Let's talk about convolutional code. Convolutional code is an error control code invented by ELISA in 1955. It was used in a large number of applications in digital transformation over satellite and the wireless channels. Convolutional code is a kind of error correction code with memory. The coding rule is to encode k bits of information into n bits, and then encoded n elements are not only related to the current input K information, but also related to the previous L group of information. And its structure is shown in figure 2, which is from Goldsmith's work on convolutional codes. Next, we introduce turbo code. Turbo codes are later than convolutional codes, but their performance is not weaker than that. Turbo code is a parallel cascade convolutional code proposed by Barrow in 1993, which combines the component codes and random interleavers in parallel cascade structure, realize the idea of random coding, and use soft input and soft output decoding methods to achieve performance close to the Shannon limit. This is turbo code encoder. There are several concepts involved in turbo codes, such as the component codes. In turbo codes, the component code encoder is an important part that generates system information and checksum information. When turbo codes were first proposed, there were two types of codes: packet code and convolutional code. And in later studies, it was found that convolutional codes have better performance. The next is interleaver. Interleaver are also an important part of turbo codes. The interleaver of a communication system is designed to combat burst errors in channel. The more important function of the interleaver of turbo codes is to make the code weight distribution reasonable, reduce the correlation of the data sequence, and thus achieve random coding. The interleaver record reorders the original data sequence according to a given rule and outputs it. The interleaving is the inverse process of interleaving. The choice of interleaver has a significant impact on the performance of turbo codes. According to the Shannon theory, the longer the code length, the greater the coding gain. Therefore, the longer the length of the interleaver, the longer the code length of the turbo code, and the better the performance. In addition, the interleaver's interleaving rule is also an influencing factor. In this project, in order to verify the effect of interleaver on data transformation, we choose the simple random interleaver and the inverted interleaver in the experiment. Let's talk about random interleaver. A The random interleaver refers to an interleavers that randomly generated interleaving mapping relations, and it is designed as follows. The number one is a sequence of message of length n is fitted into interleaver, marking the position of each bit in the sequence. Number two is generate an each unequal random numbers in the interval from 0 to n minus 1 and bind them to the marked information bits in the interleaver. The next step is arrange the n random numbers bound with information bits from similarest to the largest, and the corresponding order of information bits is changed. The last step is the random interleaver is read out from the interleaver in order of the new information bits. The advantage of random interleaver is its randomness and simplicity, and the randomness also leads to a certain degree of theory correlation in its generation method. Due to its random nature, the random numbers generated at an adjacent position may continue to be adjacent or small in distance, so that there is a situation that where adjacent bits of information remain adjacent or small in distance after random interleaving. The inverted interleaver is relatively simple and simply outputs the input sequence in reverse order. This method requires less computing resources and has a short interleaving delay, but the correlation between the sequence before and after interleaving is large. After introducing the above related concepts, we came to experimental part. We use BPSK modulation and demodulation, and the channel environment is the AWGN channel. BPSK modulator in MATLAB is to construct the modulator and the demodulator. This part is how to build BPSK. This part is how to build AWG channel. For the first experiment, that's to experimental verification of the effect of different signal to noise ratios image transmission. We vary the different SNRs in the channel so as to observe the output with different SNRs. The image output is showing in the figure. As the signal to noise ratio decreases in the coding process, the quality of the image transmission is improving. Signal to noise ratio is very important to metric industry, and increasing or improving the signal to noise ratio is a major task to improve the quality of communication. The improvement of the signal to noise ratio can greatly improve the efficiency of data transmission as well as reduce the loss of business. For the second experiment, analyze the transmission performance of convolutional code and the turbo code. We pass the image through convolutional and turbo codes to observe the output respectively. The result as shown. The original image on the left, the modulated and over channel demodulated image in the middle, and the arrow sequence on the right, with the channel The first row is the convolutional encoded image over the channel. The second row is the image after turbo coding over the channel. As we can see, the turbo BER is close to 0, while the convolutional BER is still high at 0 dB. Experimentally, both convolutional and turbo codes achieve good results, but if in industry, this 6 dB improvement could bring gains in the millions. The third experiment is to analyze the effect of interleaver of two turbo code on image transmission. We choose here a random interleaver and an inverted interleaver. The results are shown in figure. The original image on the left, the modulated over channel, and the demodulated image in the middle, and the arrow sequence on the right. The channel SNR is -6 dB. The first row is the image over the channel with a random interleaver. The second row is the image with the image inverse interleaver over the channel. Comparing the received image with the original image after the turbo image transmission systems with the random interleaver and inverted the interleaver structure, it can be seen that inverted interleaver has better performance in the transmission system. The experiment is over. Let's talk about conclusion. Channel coding has become an integral part of modern communication system because of its ability to control errors in the transmission process for reliable data reproduction. Turbo code is a milestone invention in coding theory and has received a lot of attention from scientists. And it has been widely researched and applied with excellent performance. And a lot of research results have been achieved. In this paper, we discuss the design of turbo codes, especially the design of interleaver. Based on the coding and decoding structure of turbo codes, the data transmission efficiency of convolutional codes is compared with that of turbo codes. And the performance of two different types of interleaver is compared. Experiments show that turbo code performs better than convolutional code in data transmission. Under the third environment, inverted interleaver perform better than inverted interleaver. The interleaver of turbo code also has a spiral interleaver, which maximize the distance between adjacent code elements after interleaving, increasing the minimum distance of the code word and improving the distance spectrum of the code word, thus improving the decoding performance. Thank you so much for this. Thanks for listening.